Is that on the... Oh, it was working. I went to sleep. Right. Right, all right, that's it. So we're going to have what's known as a wave. Yeah, because you need a low frequency, otherwise you won't see the vibration. Do you see? So that you got a wave which progresses through one end or the other. That's a strobe light, which I thought helps the effect. So we've got the auto. Yeah, do you see? So you see that's half a wavelength. That's another half. That's one whole wavelength, and then you got two wavelengths. So we've got two half wavelengths, and another two halves. You've got one wavelength. So wave is a form of transporting energy. When nature uses a wave motion to transport energy. As we speak, the air vibrates like a wave, and as it does so, it reaches your ear vibrates with the same frequency, and then you've got nerve receptors behind your bones in your ear, behind your eardrum, that passes the energy through the nerves, which pass the same energy, not much energy is lost, into your brain. Then it goes through a certain complex molecule, which hasn't yet been discovered. Oh yeah. So future PhD students to be discovered. Okay, and then that turns into a sound. Yeah, amazing, absolutely amazing. So you got interaction of, matter and atoms. There's something going on there. Do you see? So, and look at that. So this is like two half wavelengths. That's one wave and two waves. But we could. So you're videoing that, yeah. So these nodes are, the net vibration is 0, yeah? And these are antinodes, which is maximum vibration, yeah? And then we've got, right, so what you see, what you see is one whole wavelength this time, because you've got a lower frequency. So that's one half, another half, one whole wavelength. You remember from your level physics, yeah? So you can alter the frequency to, the lower the frequency, the longer the wavelength. The higher the frequency, the shorter the wavelength, as you can see that from this particular experiment. So this is low frequency, therefore longer wavelength, yeah? So that whole wavelength is that distance. Longer wavelength, one half wavelength, and another half is a whole wavelength. So you've got a long wavelength, which is the distance between these two, yeah? And that will be one whole wavelength. That means you've got longer wavelength, shorter frequency. But if I now increase the frequency, the wavelength will be shorter. Now look, so the wavelength now is there. Look, it's shorter. So one half and a half. So the wavelength is shorter. Why? Because you've got higher frequency, higher energy. Yeah, you've got high energy, higher frequency, therefore shorter wavelength. You see, yeah. And if I make it even shorter, the wavelength, by increasing the frequency. Yeah, do you see? So now, look, that's one, I'll make it even shorter. Do you see? So you've got one half wave, another half. So the wavelength is shorter because the frequency is higher. The wavelength is shorter and the frequency is higher. In fact, this is a frequency of 46.7 hertz. Higher frequency, yeah? Higher frequency, shorter wavelength. That's the frequency, yeah? Meaning you got more energy. So gamma rays and X-rays can penetrate through your bones, or X-rays can be absorbed by your bones but penetrates your flesh. Gamma rays can go through your bones, and it's not really stopped by anything apart from at a certain distance lead, yeah? But even if it's close to the lead, it will go through the lead, gamma rays. So because it's got high frequency, shorter wavelength, so it can penetrate, squeeze itself through the atoms of the material. So very penetrating. And then if I lower the frequency, then I should be increasing the wavelength. Yeah, so the wave, you see, so the wavelength increased. That's one whole wavelength. Look, one half, because I lowered the frequency to 22.68 hertz, which is lower than before. So lower frequency, longer the wavelength. So frequency and energy are proportionate; they're equivalent. Yeah. So the lower frequency means less energy, longer wavelength. So like radio waves, which is how televisions work, or infrared, have long wavelength, so they cannot penetrate through solid materials so well because they've got lower energy. So I lowered the frequency, yeah. So now it's 22.68 compared to what was it before, 48 or something, yeah. So therefore, lower the frequency, longer the wavelength, which is less energy. Longer the wavelength. Look, one half. Recall before the wavelength was there. Yeah, but now the wavelength is from these 2 points which are further away. Okay. So wave motion is a very important way in which nature transfers its energy. Yeah. Okay. Does that make sense? Yeah. So I hope you enjoyed that.